Okay, we have a very interesting question here. A ball is projected upwards with a velocity of 128 feet per minute from a height of 5 feet above the ground. So when the ball is thrown, the path of the ball follows the shape of a parabola, which is actually modeled by a quadratic equation. And that's exactly why we have a quadratic equation in this problem. ht equals negative 16t squared plus 128t plus 5. So the first question is, when will the ball reach its maximum height? So I just pulled out the graph from my Windows calculator here, and look at the graph only above the x-axis or the t-axis, because t-axis represents the ground. So we are only seeing all the action that's happening above the ground. So when you are looking for when the ball will reach its maximum height, first of all, let's see what the maximum height is. Based on this picture, the maximum height is the vertex of the parabola, the very top, the peak. So that vertex is given by, if you have a standard quadratic equation, ax squared plus bx plus c equal to 0. So the vertex, the x coordinate is given by negative b over 2a, which is our x coordinate value. In this case, it's the time axis. So that tells us when, answers the question when, how many minutes to reach that maximum height. So all I did was, like when you compare the standard quadratic equation with the equation that's given, we have the value of a to be negative 16, b is 128, c is 5. So I just substituted for b and a in the expression negative b over 2a, and I calculated that. It comes to 4 minutes. And the graph also actually shows us the same information. The t-axis is going by 1 minute per square, and it's perfectly 4 minutes. You see, the ball is at the very peak. So that height, in order to calculate that height, you take this value of the t coordinate and plug it into the original equation. So that's what I did. So you can see here, part B. So you substitute t equal to 4 in the original equation, simplify, and you get 261 feet. So that's the maximum height. I also labeled that in the visual. Now part C is find the x-intercept and explain its meaning in the context of the problem. So x-intercept is the value of the x coordinate when the value of the y coordinate is 0. That means when ht equal to 0, when the height is 0, we have to solve for t. So that's what I did in part C. I didn't show you all the detailed calculation here, but I kind of put a decent spot. When you simplify the quadratic formula, it takes you here. You get two answers, t equal to negative 0.08, t equals 8.07. And we know negative 0.08 doesn't make sense in this context. So that's rejected. So let's go to the part where it says, explain its meaning in the context of the problem. So this means when ht is 0, that means the height is 0. And it says time is 8.07 minutes. That means, like, while the ball is being projected upwards, remember, like when the ball is tossed up, there is that little time frame from the minute it leaves your hand and goes up, right? So that time is actually 8.07 minutes. And in this graph, it's also the place where the uh, parabola crosses the x-axis. So that's how we have this t equal to 8.07 by solving the equation for the value ht when ht is 0. Okay. Next is part D. Question is, after how many seconds will the ball be 100 feet above the ground? So now this time you plug in ht to be equal to 100 and solve for t. So we get two values for t, 0.828 minutes and 7.18 minutes. So if you see in the graph, we actually have, let me mark this in, I'm just marking it right now with my black marker. You can see the place where I marked on this curve, that's when the height is 100. So t, it looks like in this graph it's almost 1, but it's actually 0.828 minutes. So converting that, it comes to 49.68 seconds or close to 50 seconds, almost, but less than a minute. Then the other time, the ball comes down and when it's 100 feet above the ground, that's at 7 minutes and 11 seconds. Part E is find the y-intercept and explain its meaning in the context of the problem. So y-intercept is the value of y coordinate when the value of x is equal to 0. So when you put t equal to 0, what do we get? In the original equation, you put t equal to 0, we get ht equal to 5 feet. And remember, the question actually tells us the significance. So when the ball is being projected upward, the person is actually 5 feet above the ball is actually leaving at a height 5 feet above the ground. So like the person lifts his hand and tosses the ball. So maybe that height from the ground, from the hand to the ground, it's about 5 feet. So that's what it is. This was a very interesting question.